My name is ygoldfed, and this is my submission to the Powered by Sefaria contest. So without further ado, we'll first go through what my project is, and then I will explain how to use the server that I set up. So what is this? So tool I made is called Scribe. It's a tool for punctuation prediction. That means basically taking a Sefer, taking a text file, and adding periods, commas, quotation marks, etc. So why do I think this is important? Well, many Sefarim don't have any punctuation, and many of the Sefarim that do have punctuation have very little punctuation, right? For example, if you take a look at the Ritva and Sefaria, I believe, or some others, lots of other Mefarshei Talmud, they have periods every now and then. They have no commas. You know, there is punctuation. It's not so great. So, and as Sefaria's library grows, as more and more Sefarim are read from PDFs, so that if they don't have punctuation, this is only going to become a larger issue. So this is an attempt to solve that by automatically generating punctuation. Okay, a bit about myself. My name is ygoldfed. I graduated from YU. I graduate from YU this September. I've been a big user of Sefaria for a long time. I think I learned all of Mor Nevuchim on Sefaria, thanks to Sefaria. I've also used Sefaria as a reference for quite a while. And I'm really very thankful to Sefaria, and I hope one day this can become part of it, this project. So now I want to go through the 4 criterion outline for the contest and why I think this satisfies them. Highlighting the unique value of Jewish text. Well, I think leveraging state-of-the-art techniques to explore and to amplify Jewish text just shows how important they are to us. Technological accomplishment. Well, I spent a long time working on this, and punctuation tagging is actually quite a difficult problem. I've read most of the literature out there. None of it really works, and it's all aimed at English, which is a bit of a different beast. So this is really a cutting-edge problem, and I think I have decent results that I'm proud of. So I think that satisfies that. I do want to add, there was a lot of experimenting going on. Some of it worked, some of it didn't work. I tried, just to give you guys a sense of what I was working on, I tried using the transformer architecture, which is a newer NLP architecture, neural network architecture. Did not get it to work, but luckily there were lots of things that did work for me, which I'll explain in just a minute. Potential for impact or inspiration. I think this tool, God willing, will have a lot of impact. It can let people more easily read Sefarim, right? There's punctuation. Punctuation is there for the reader. Right. One of the big goals of Sefaria, obviously, is to make it easier for people to learn Torah. Punctuation will help them do that. Also, this might be a bit less obvious, but equally important, punctuation is actually a requirement for many downstream NLP tasks. They just assume that there's going to be punctuation. So this will enable files that don't have punctuation to have creativity. People sometimes think that machine learning and I guess software engineering in general is very dry, but it actually takes a lot of creativity. I tried a lot of things out. Some of them were quite wacky, and some of the wacky ones even worked. So there was definitely a lot of creativity in this project, and luckily some of it actually worked. I do also want to add that this is truly powered by Sefaria. All the training data for the neural networks came from Sefaria, and all the canonical texts that the citation identifier looks for all came from Sefaria. Okay, now let me give a brief overview of what actually happens. So a file is input into the program. It is then run through a preprocessor. The preprocessor basically removes all non-Hebrew characters, and as well as illegal characters, things like that. Converts characters to more logical representations, like for example, Ger Shayim becomes a quote, things like that. That is fed into an embedder. The embedder converts each word to a word embedding, which is a vector representation of that word. It also uses a stemmer, which tries to reduce Hebrew words to their roots. This is useful because lots of words aren't in our vocabulary, but their shoresh often is. So that's very important. And then after words are embedded, the embeddings are fed to the neural networks. I actually have 20 neural networks here because they're really solving 2 separate problems. This group over here is solving the problem of generating stop points, which are basically, is there punctuation or is there not punctuation in the text? And the second one tries to identify what those stop points are. It's commas, a period, etc. The reason why I split into 2 is because punctuation has quite a class imbalance. Most points don't have punctuation. And this architecture just worked better than a single network. And the reason why each of them are actually split into 10 networks, that relates to k-fold cross-validation. and then averaging all the networks together. Doing this, it increases precision over recall, which basically means that it reduces the likelihood that I will put a comma in the wrong place, but might increase the likelihood that that I will miss a comma. But I'd rather miss a comma than put a comma in the wrong place, which is why I'm using an average of these 10 hours. And then all of that is fed into. Oh, sorry, I'm going to go back here for a second. Existing punctuation is also taken out of the document because if there's something there, it's probably useful. And then going back to the preprocessor, it's fed into a locality sensitive hash. I'm using something called min hash. What this basically does is it takes every n-gram of length 4 in Talmud Bavli, Yerushalmi, Tanakh, Mishnah, Tosefta, and Medrash, and it hashes it using a locality sensitive hash, which means that even if there's going to be a typo or there's going to be a morphological variant like missing a vav or something, it's still going to find the quote. All of that is fed into a constraint satisfaction solver. This is my biggest innovation. I don't think anyone's ever done this before. Basically, the idea here is that these neural networks, they're very good at guessing, but they don't know basic structural things. For example, they don't know that you just can't put two periods next to each other, two commas next to each other. So what this tries to do is it tries to take the probabilities from these networks as well as the existing punctuation and the citations and tries to make it make sense. It has rules like a sentence can't be less than 5 words. So I basically enumerate a set of rules or constraints, and I try to satisfy them while minimizing the error, while minimizing the error of the probabilities. This is actually quite a difficult problem. I think it actually runs in exponential time, but I'm running in linear time because I'm just using a greedy algorithm that does a pretty good job. But if you actually want to solve it, that's a pretty hard problem. The greedy algorithm works pretty well, and that's put into the output file, and it actually works. I have more details in some other slides, but I think that should really cover it. I'll post the slides here. Without further ado, let me show this in action. So I will post the URL for the server in the description. If the server is not working, that's because I'm using Google Cloud Free tier, which sometimes just shuts down randomly. I will try my best not to have that happen. If the server happens to be down, please reach out to me by email. I will respond quickly. I'll put it back up. So let me explain how this works. Basically, so 2 things about the server, 2 limitations of the server. Number 1, because this is running on a CPU, it's not as fast. So please only input files of around maximally, I would say 3,000 words. Otherwise, it's going to take too long. And also, this server does not have citation finding. It only has adding the commas and the periods. The reason is because the citation finder just requires more RAM than I could provide on a free server. You have to have all of Tanakh and Bavli or Yerushalmi, etc. in memory. I just couldn't do that on this server, so just have periods and commas. But let me explain how it works. You upload a file. It should be here. This is Pnei Yoshua and Brachos. It's not the whole thing because it's too big for the server, but it is the first 4 dafim or so. I do want to stress that limitations not in the program. It's just on the fact that the server is running on very, very, very iffy hardware. So I click open, I upload the file, and then I click upload, and the server says waiting because it's now running the predictions. Once again, this should be a lot quicker if this was on a GPU, but it's not. Just wait a minute. And there we go. It downloads the file for you in the form output.txt. We open it up, and here we have the Pnei Yoshua first 4 dafim Masechet Brachos with punctuation. Scroll through it. It seems pretty solid. Definitely are some mistakes, but I would say it's pretty accurate overall. You can, as I said, you could put any file you want here. I'll include the link, and but it should be maximally 5,000 words. I mean maximally 3,000 words, only because the limitations of running this stuff on a CPU. That is my project. Thank you for listening, and I hope you like it.